Good afternoon, everybody. Thank you so much for being here. Um, I know there's still some people coming in, and I know that we're at kind of a in between half hour, so I think we might have more people joining us throughout this session today. We are here for the third session of our CLIR Climate Resiliency Action Series. We are focusing today on the idea of combating climate anxiety through data. We do have shared notes that can be used throughout the session today. So I will share that link with everybody here in the chat. I'm running the slides and sharing the links. So bear with me for just a second. Okay. And so please do join us on those shared notes. All of our shared notes will be eventually added into our repository that we have for this project. And so to talk a little bit about the project, we're in the middle right now of a larger series. The series is put together with scholars from across the United States who are looking at some intersection of climate science, libraries, museums, data sciences, data management, and how those fields can work together. So today we've got a really interdisciplinary panel who's looking at how we can look at these intersections of climate data and archiving that information for further use. So I'm really excited about where that's going to go. So over the course of this entire series, the big picture is that we will have 6 of these thematic series sessions, and then we will have 6 community-led climate circles that will follow each of them. So we've done 2 so far of each of those. So next Friday, you can join us for an informal kind of community-led climate circle that will allow you some time to kind of talk about what you hear today, how you might apply it at your own institution, and how you might carry that forward with you. Throughout the year, we're also going to do some in-person networking. Stay tuned for that. There's some events coming up in early 2025. So we'll share that through our CLIR networks as well to tell you more about it. And throughout the course of this process, we're building a community toolkit that's going to have, key terms, glossaries, hopefully some data sets through the end of it, but also our shared notes and just kind of a shared repository of what we've learned for all of it. As I said, we're about halfway through now. This is completing our fall slate of panels, and we will be picking up again in January. So if you've been joining us through this series, we have looked at a lot of kind of very skills-based work so far and how you can apply these things at your libraries. Today, we're going to kind of look at this as a relationship between scholars and institutions. And then in January, we'll pick back up with a session on Indigenous knowledge and climate collaboration. And as a thank you, I just want to mention some of our partners. This is funded by an IMLS National Leadership Grant. So we're very grateful to IMLS for that funding, for allowing us to put this program on for free and to be able to provide it perpetual access to it. We have great partners at CLIR who are helping us to make sure that this keeps the wheels on and keeps running. So Wayne Graham has been a great help, as well as Alice Rubin, who has kept all of this together behind the scenes. We have a brilliant advisory committee who helped to kind of conceptualize the entire program and what it would look like, with Lisa Spiro, Justin Wadland, who are both our co-facilitators of the DLF Climate Justice Working Group, as well as Amy Dreyer and Lena Zentel, who helped to kind of originate this plan. And then we have a curriculum committee who helped put together and plan out each of these individual sessions. And so that was made up of Jennifer Waxman, Jennifer Embry, Jody Gray, Trevor Bond, and Steve Diggs, whose name is off the bottom here, but you'll spend a lot of time with Steve today. And so you'll have some more from Steve here. So Steve is going to lead you as the moderator today through our session on combating climate anxiety through data. And he's going to start by introducing our panelists.
Thanks, Amanda. First up, you'll hear from Dr. Amanda Whitmire. Amanda and I go back a ways doing data rescue, and she has a scientific background in oceanography and also has a role as a librarian And she's dedicated to preserving and sharing valuable historical data, and that's how I know her. Currently, she serves as the head librarian and bibliographer at the Harold A. Miller Library, where her expertise in digital curation and open science principles informs her work in supporting climate change research by transforming historical archives and collections into actionable data. Next up, we have Dr. Mark Merrifield, who's a professor at Scripps Institution of Oceanography at UC San Diego. Mark and I met years ago, and he's had a couple of different careers in different places. At least he's a distinguished climate science and sea level research expert, and he directs the Center for Climate Change and Impacts and Adaptation at Scripps Institution of Oceanography. He returned here because I'm actually physically sitting at Scripps after a 20-year tenure as the director of the University of Hawaii Sea Level Center. His research focuses on sea level rise, climate variability, coastal oceanography, and nearshore processes. Mark's work aims to advance the understanding of climate impacts, providing meaningful projections and develop practical solutions for societal benefit while preparing future generations in adaptation strategies. And then bat and cleanup, we have my friend Stuart Sandin. Dr. Stuart Sandin is a professor also at Scripps Institution of Oceanography in the Marine Biology Research Division and the Center for Marine Biodiversity and Conservation, where he is the director. His research focuses on how marine organisms interact, particularly in tropical coral reef ecosystems, aiming to balance fishing demands with the longevity of fisheries. He leads ship and land based expeditions to study the impact of human activities on coral reefs, which inspired the 100 Island Challenge, a regional study of coral reef health. So, those are our three speakers today. Next slide, please. And I'll introduce myself. So I am a senior research data specialist at the University of California. For those of you not in California, the University of California is a very large university. I believe we may be the sixth largest university in the world when you totaled it up. 10 campuses, 3 national laboratories, and 5 medical centers. We have a population, if we include faculty, staff, and students, of just about 500,000 people. Next slide, please. We have about $180 million in research budget, depending on how you look at it, with a climate resiliency research of about 100 million. There are several key research locations. One is Scripps Institution of Oceanography in San Diego at UC San Diego. The other major one is the Bren School of Environmental Science at UC Santa Barbara. Some of the research activities include climate science and impacts, but also policy analysis, renewable energy innovations, sustainable agriculture practices, and data science, which is where I work at the intersection of data science and climate research. Next slide, please. In my career throughout the years, I've worked with some of our researchers who are on the panels, either at sea or on land. If it is put in the water or goes up in the sky, I probably either programmed it, taken data from it, or deployed it, or all three. In my recent years, I've worked for the School of Research Data Science, where we onboard early career scientists in research and data science in good curatorial practices. So I have some background that gives me a knowledge about what all of our researchers are doing, and I'll be your moderator for today. So first up, we have Dr. Amanda Whitmire. So and you can skip that slide in the interest of time.
Okay, so I'll jump in. Let me get my slides up on the screen for y'all. You should be seeing my opening slide. Perfect. Thanks for the
We're
thumbs
good.
up. Okay. Hi, everyone. It's great to see you here with us today. I'm just going to be with you for about the next 15 minutes or so, talking about how I think about my role in collections as data and service of the planet. So let's get rolling. So as a sort of lead into my focus for the next 15 minutes, I'm just going to start by briefly describing my context because it's a little bit unusual. I'm a biologist and an oceanographer by training. I learned how to become a librarian on the job, really, through praxis. I started as a data librarian at Oregon State University in 2012, and then I moved on to become the head of this marine biology branch library in late 2015. So I'm located at a marine research field station, so I'm not on main campus, I'm down at the coast. And this marine station has been here for over 100 years. So the collection that I work with in my library is, reaches back a good ways and has a very local focus on the Monterey Bay area and the California coast. But beyond working at this field station, I have access to the resources of sort of Stanford Library's digital infrastructure and beyond. So even though I'm located here in a small branch, I have a lot of resources behind me at main campus. So I have the luxury of working in a relatively narrowly defined subject area with a deep and focused collection. And that's my library there at the end of the rainbow. It's wonderful. I'm looking at the ocean now. Thankfully, there's no tsunami. I don't know if any of you heard about the alert, but we were watching out for that this morning. But anyway, the nature of me being embedded here in this research community really heavily informs my praxis. And so that's what I'm going to share with you today. And I want to give you the main point of this, of my section right up front, so you know what you're in for. And what I'm going to hopefully convey throughout my presentation is really how engaging in collections as data work sort of helps me alleviate some of my own climate anxiety by giving me a sense of purpose and agency over what feels like a really intractable problem. Like climate change is a scary thing and a big thing. I don't expect that all of you out there can or should engage in this kind of work, but I think more broadly, I hope that as information workers, we're sort of endeavoring to reflect on how we can best meet the needs of researchers who are engaged in climate work or climate-related work. Mark and Stuart will give you a couple of case studies on their work and their information needs and challenges. So I think that'll be a good follow-on to sort of what I'm talking about with respect to library collections. So given my sort of personal and professional mandate to support the research needs of the Marine Station and beyond, what I think about a lot is what do my researchers need and how can I best support those needs, whether it be research or teaching or whatever. And the quote in front of you there is from a research paper co-written by a faculty member here at the Marine Station, Theo McKaylee. And it really gets at this idea that there are significant gaps in observational data sets, whether it's biodiversity or oceanography, to be able to tackle problems like how species ranges are changing as a result of climate change or how the oceans are changing. You really need data over scales that can answer those questions. And at this point, there are still observational gaps. So from my view, I have materials in my collection that can help at getting to fill some of these observational gaps. And that's what I'm really working toward as a part of my job here at Miller Library. So to give you a sense of, from an oceanographic context, what those gaps look like, here on the left, I'm showing a time series of oceanographic profiles or casts down into the water column from what's considered really the most comprehensive oceanographic data set in the World Ocean Database. And you can get a sense of it looking back in time, of course, that as you go back further in time, there are fewer profiles to work from because the ships just weren't out there and couldn't cover the area. Same data plotted in a spatial context on the right-hand side where darker colors, either black or white, show areas where the ocean is undersampled. But over a 300-year time series, even if you're in an area where there are a few dozen casts, that doesn't really provide the kind of coverage that you might need to answer questions. So more data is always better. In a biodiversity context, I like to explore sort of what the data environment looks like by heading over to GBIF, the Global Biodiversity Information Facility. It's really the largest database of species occurrence records that we have. It's currently at over 3 billion occurrence records. So by way of example, let's look at Hermescinda crassicornis. The thing that is great about GBIF is that you can look at species occurrence data. So that's, I saw this thing at this place at this time. And if you look at the species occurrence records for Hermescinda crassicornis, the opalescent nudibranch, which is a common nudibranch here off the California coast, you can see that the distribution is mostly centered off of the west coast of North America. And in GBIF, there are over 4,000 occurrence records. And that really sounds like a lot. Like, wow, that's a lot of data. But if you go one step deeper into the data, what you'll find is that the observations are heavily skewed to about the last 10 years. And there are observations going back in time. You can see a little blip in the 70s and so on. But from my perspective and from the researcher's perspective, it would be really great to try and fill these gaps going back in time so that they can have a better baseline for what environmental change is going to do to the distribution of species like the opalescent nudibranch. So I can't see you out there, but I would ask if we were in person, if anyone had a guess as to why this distribution has this big spike starting in about 2008. And maybe some of you are already thinking of it, but it's iNaturalist. So the reason we have all these observations now growing really fast after 2008 is iNaturalist. So if you're a nerd like I am, good job, way to go, citizen science. We're really adding to species observations out there. So that's the context, oceanographically, biodiversity, there are these data gaps, especially as you go back in time. So I'll spend the next sort of last part of my talk just sharing a couple of case studies from our collections here at Miller Library that really sort of show you how I think about transforming our collections in a way that can create actionable research products and help sort of inform our understanding of the changing environment. So as I mentioned, Hopkins Marine Station's been here a long time. The station was founded in 1892. It was the first marine station on the west coast of the US, and we're located at the star at the map on the right there to give you a sense of it. We're on the coast of Central California. And our oceanographic sampling program here at Hopkins started in the late 1920s, 1928, and continued through 1937 at a station out in the middle of Monterey Bay. You can see that map just to the left of the large-scale West Coast map there, shows some sampling stations. And starting in 1950, Hopkins Marine Station got a research vessel. And so they started going out into the bay starting in about 1951, and they visited 6 sampling stations every week for about 25 years. The 2 photos on the left are from the 1950s, and they're part of our early efforts in the Cal Coffee program, which if you're from coastal California, you may have heard of before. So here's one example. What I'm showing here is a data report. It was published with well over 100 pages of data tables, literally, that include ocean temperature, salinity, oxygen, phosphate, and silicate. And like I said, it was more or less weekly sampling out in Monterey Bay, in this case at one station, a deep station from the surface down to 800 meters. So we scanned the report, and when I say we, I'm talking about, I have a digital project specialist. Her name's Melissa. She works half-time, and almost everything I'm showing is a collaboration between me and her, with her doing the heavy lift on the digitization and transcription work. So we scanned the report, we transcribed it, first using OCR, using FineReader. It's a tool you may have heard of. It's pretty good at extracting tabular data from scanned data tables. And then Melissa went line by line for every page of the report and double checked all of the data, so we're confident that it's as accurate as it could be with human eyes. And then we turned that into a CSV, a data file, and we deposited it into Stanford Digital Repository. So we started with the physical report and we finished with the data set. Is SDR the best place for this data set? Like, probably not. It would be more discoverable to oceanographers if it was in the World Ocean Database. And so we're exploring the possibilities of depositing our data set there as well. But that's in the works. We're working on it. And there's more data that we have. So Hopkins was involved in the Cal Coffee program for about 25 years. So there's all kinds of data sets we're working on to publish. But so far we have phytoplankton and zooplankton biodiversity data, diversity and abundance at least, published in Stanford Digital Repository, along with some oceanographic data. So what we're working on now is we've already transcribed weekly oceanographic data from 6 stations in Monterey Bay from 1954 to 1978. and it is languishing on my Google Drive, but hopefully soon will be in Stanford Digital Repository. So before I move on to the next example, I just want to emphasize that what I'm showing here is a process that extends traditional digital collections work into being what we call collections as data work, because we're extracting data from the scan materials, making them available as computationally accessible data sets. This lowers the barriers to use for our researchers because they really are not likely to want to wade through 100 pages of a PDF to get to oceanographic data. Like, they just do not have time for that, right? Data sets are much more useful than PDFs for the research community that I support, which is why we invest the time and the resources to transform our materials in this way. And I'll just go to a second example, my last example. This is maybe something that will be intuitive to most of us here, because I think you've all probably seen, if not created, your own thesis or dissertation. So this is a dissertation example. The story starts with the dissertation and continues to this day, but we had a graduate student at Hopkins Marine Station starting in 1931. His name was Willis Hewitt, and he began a survey of an intertidal transect line at Hopkins Marine Station. So the transect was 105 yards long, started on shore and went out into the intertidal. And he counted for every square yard of that transect, every animal and plant that he could find. So this really started a baseline for intertidal species diversity at Hopkins Marine Station. And then in 1993, two undergraduate students, Rafe Sagrin and Sarah Gilman, for their spring research project, decided that they wanted to resample Hewitt's transect line. So after they eventually found the brass markers that are driven down into the rocks in the intertidal, they were able to resample 19 of Hewitt's transects of the 105. When they compared the species abundance data with Hewitt's data, what they found was that the species abundances have shifted more towards southern species or more towards warmer water species. They combined those observations with Hopkins' daily temperature record, which goes back to 1919 as a part of the Shore Stations program, which has run out of scripts. And they speculated that the species shift had to do with changing ocean temperatures. So they came back the next couple of years to collect up more data, and eventually were able to publish a paper in Science that demonstrated long-term biodiversity changes related to changing ocean conditions, which for two undergrads is a pretty big deal. So Rafe continued on sampling the transect for his graduate work at UC Santa Barbara, and we still to this day can sample the transect line here at Hopkins, and it's become to be known as the Hewitt-Sagrin transect. So how do we think about this in a collections as data context? So for the Hewitt dissertation, obvious first step is we scanned it, of course. The second step was that Melissa, again, extracted all of the data tables from the dissertation, which included a list of species that Hewitt observed along the transect, along with their abundance data. So like I said, this provides a really important baseline for researchers at Hopkins who are studying changes in intertidal biodiversity going back almost 100 years now. And now all of those data tables are available in Stanford Digital Repository. So that's it. I'm going to stop there. I could keep going on this for a long time, but I'll pass the torch now. So just to summarize again where we started, I really sort of have a personal mandate to engage in this work in transforming my collections here at the Marine Station Library into actionable data sets for researchers, because it helps me feel like I'm doing something. It helps me feel like I have agency over this really big problem. If I can take materials from my collection and make them actionable for researchers to use who are asking the important questions about how our world is changing. So I will leave it there. Happy to take questions at the end, and I will pass it on to Mark, I think. So let me stop my sharing here and off we go.
Thank you, Amanda. And let me switch over. All right. Okay, I'm going to talk a little bit from my perspective of actually measuring various aspects of the physical environment that it helps us to interpret sea level rise and sea level rise impacts. And so my background is, as Steve mentioned, I was the head of the Sea Level Center. So we took care of tide gauges all around the world on the upper left there. And all the data was sent to us in near real time. And our job was to basically turn that around as a data processing center to make sure the data was useful for scientific research. And at the center, we certainly took full advantage of that and looked into sea level rise, tsunamis, tides, eddies, any number of physical processes where the surface of the ocean comes into play. And paired with that, I was also part of what's called the Coastal Data Information Program, and which is CDIP, which is the takes care of wave buoys around the U.S. And my part of that was the island region. So most of the green dots out in the middle of the Pacific there were stations that we deployed for CDIP. And so with that, we were able to look at wave studies at places like Hawaii, Guam, American Samoa. And that led to my real first bout with climate anxiety. So up until then, I was happy just to understand the science of change. But there was a flooding event that occurred in the Marshall Islands on December 2008. And it wasn't just the Marshall, it was really all the islands in that region experienced an unusually strong wave event that, when paired with high tide, led to the flooding that you see here. And for the Marshall Islands, it was pretty profound because basically the whole nation was overtopped by this event. And it wasn't just one day, it was several days of this. If you focus in on the Marshall Islands, you can see why it would be such an anxious proposition to have so much water flooding over the region. This is the atoll in Majuro. There are about 40,000 people who live in this little patch of the world. And their ability to stay here is all based on there being a reef platform that they're sitting on that dissipates waves as it comes in. So the wave dissipation is very effective. It cuts all the most of the wave energy before it reaches the shore. But when the water level goes up, it is less effective. And as time goes on, as the sea level continues to rise, the wave impact is going to become worse and worse. And the whole island, all the infrastructure, the freshwater resources, the international airport, the drainage systems are all dependent on the water level being at a certain range, and it doesn't take much to become an epic sort of problem. So we went out there with the National Science Foundation funding to try and make the measurements that we would need to understand why flooding occurred in that particular sequence of events, how we would predict it in general, and how we could assess over time, when we think about adding the climate change signal on top of this, what it means for the nation of the Marshall Islands. So these are some of the data sets that were collected, and these were all archived at our library, and were some of the first that really went into detail on physical waves and water level at a fringing reef like this. That resulted in the development of a warning system for the Marshall Islands. So this is the outlook that was presented a couple of days ago, or I guess yesterday. And at different locations around the atoll, referenced by those colored lines, we tried to give a sense of when the water would be high enough where you might poke into that red area where it becomes a concern. And if you get up to the very top of that, it becomes a big concern. But this gives you 6 days or so to kind of at least prepare or get ready for an event like this. This is the model that's incorporated into our climate projections for the region. And I'll say that we went into this project completely blind, or let's say we just were ignorant of conditions on the ground. We didn't bother, or at least we didn't have the time, given the nature of the experiment, to really get a sense of what the islanders were worried about and what they cared about and what they wanted to protect. We went in with the mindset that we would tell them what the result of the study was, that we thought it would be useful for them. And so everything we did was sort of on an outreach mode, where we were giving them the output of the information, including this warning system. And we left some of our sensors there as well, as sort of part of this. But it was a very one-way street. And that left me feeling like there was much more to do and we would be much more effective if this was a co-produced project, that we really should have started with a trip to the Marshall Islands, where we just met with the inhabitants and really got a sense of what the problems were. This led to a shift in my career where I no longer was, I guess, satisfied, or I guess looking at the data and understanding the growing threat, feeling like more had to be done. And so when the opportunity came to join Scripps at the Center for Climate Change Impacts and Adaptation, that was a big, that opened up a lot of opportunities, because Scripps is a place where you can work across disciplines very effectively. So our job, as we see it, is to increase understanding of change, to develop adaptation strategies, reduce vulnerability, and participate in education and training to broaden participation. So our first project of note was to look at flooding in the community around San Diego. So this is Imperial Beach. And maybe I was drawn to this because it looks like a coral atoll, but it's very much the same issues. So when the water level's high and the waves are big, these homes here along Imperial Beach often experience flooding. And this time we did go at it with the point of view of the end user first. We met with the mayor and his team and learned that they really had no way to predict this. They were blindsided by these events because they were going purely off of a tide table. And unless it was a king tide or something, they had really no sense of when it would flood. So again, observations are the key thread that runs through all of this. So again, acquiring all the observations we thought we needed to make another model for community flooding in this region led to another prediction system that's being used by the city today. And we focused our attention on the spots along the shoreline here, which they really were worried about. And we're continuing to work with them on developing this. And it turned into what it turned out that the information, advanced warning information, was fairly useful for the city, so they could deploy kind of the personnel they need to get ready by putting in sandbags and sand walls, how they could route traffic and get advisors out. And it's become a model for us to co-produce this sort of science information and to build a product that serves our research needs as well as the societal needs. So when you think about these kind of how you attack this problem, you're trying to build resilience to some sort of climate threat. In our case, it's sea level rise and coastal flooding. So what I was describing as my first career was really looking at exposure, really getting the observations and the models and whatnot to understand what the probability of flooding would be and what causes flooding and how much flooding should we expect with certain sea level rise scenarios. The sensitivity bit was the key piece we were missing, which is how does it affect the people on the ground, the community, the environment, the infrastructure? And we had no kind of tie to that sensitivity. And the data you need to understand sensitivity is a whole new aspect of this problem that I think there's an opportunity, as we'll talk more about, to kind of build out in this area. If you understand the exposure and you've mapped out your sensitivity, you've then described your vulnerability. And then it's a question of what to do. What action should we take, and what kind of adaptive capacity do we have to adjust the system in such a way as to reduce these impacts? And for places like California, the impacts are profound. We are a low-lying area in places wherever you see estuary or water wanting to head back into the sea. Road closures, our storm water systems can be damaged. We have a lot of infrastructure that's right along the coast. Our beaches and our cliffs are subject to erosion and cutback, and a lot of our economy is based on a coastline that can be seriously degraded over just a few events during high tides. So this sense of taking action really depends on having some sense of what's coming, what's happening now, and to be proactive about your intentions and how you're going to try and build some resilience to the system. So the upper panel is the best case where it's a science-informed planning, equitable and adaptive risk management. More likely, we're dealing with a case where we're reacting to the change. A storm comes through and we're wondering, well, how to build back from that, or where is it equitable to build back or smart to build back? And sorely underfunded in terms of how to respond to different impacts. So that's the pathway we want to avoid. And just to put it into a more specific context, this is on the left here is just a plot of sea level rise with broad uncertainties going forward to the end of the century. And we might wonder, well, to protect a particular shoreline, what sort of pathways would we follow? And so we might start by just gathering the sand from offshore, bringing it back to the beach, called a renourishment, which is very common out here in California. And at some point, as sea level rises, that will no longer be a viable strategy. And at some point, we would hope that we were collecting data or collecting information that would trigger us to move to a different pathway. So you want the observations to guide you before you get to this sort of worst case scenario where you really you're experiencing the brunt of these disasters, and move to a second pathway here, another adaptive pathway A, where you might be installing living shorelines or more engineered shorelines for protection. And as sea level continues to rise again, there'll become a point where you'll be triggered to that this is no longer viable, and again, move to another pathway. So this might be pathway B, where some sort of relocation might be necessary just to ensure that you have the safety thresholds that you need. So the key thing here is that you really need data to set triggers for you to make decisions. And those decisions aren't totally based on physical measurements. It's not just how high the water is or how often it floods, but how is your infrastructure affected? What is the economy of what's going on? How much does it cost? How many people are affected? And who is going to be able to pay for the change? All of those sorts of decisions need to go into this adaptive pathway formula. And it requires a whole new way of thinking about data. So the kinds of data sets that I'm used to collecting are stored in such a way that another researcher could go back and reproduce my results just based on the information. But we need to know information about what the city cares about. What are the important infrastructure points? What is the, where are the sewer lines located? Well, all of these sorts of value kind of determinations requires a data set that goes hand in hand with the physical data, and together they're needed to understand how to make effective choices. And just to, not to add, but, underscore that sense of anxiety, this is talking about adaptation that will work for a while, but we're going to get to a point where sea level will rise to such a level that we won't recognize our shoreline. And this is certainly happening back in the Marshall Islands here, where these flood events and as sea level rises, their threat, what they care about is fresh water on the islands. And at some point, as all the salt water overrushes, it overwhelms their reservoirs, and the habitability of the whole island becomes a concern. So I think we need to start to evaluate what these critical vulnerability points are for each of our communities, and to really dig in to the observations needed. From my point of view, some of the things that I know would help my work and help kind of the projects we work on is we have models of when it will flood, when it's likely to be a threat, but we don't have the observations to really validate that, and surprisingly so. Although they obviously exist. So there's a lot of information about when did it flood, where did it flood, how long was it, how deep was it? A lot of that historical information is in newspapers. A lot of the current information is in social media. And there needs to be ways to harvest that information in a way to validate the scientific research. We need the socioeconomic data to understand sensitivity, people, infrastructure, environment to rising seas. We need the data to make these decision relevant information including triggers for planning adaptive pathways. And as we start to think about how to bring these various data sets together, it's all in the spirit of production, co-production of knowledge, beginning with what the end user's needs are, to develop collaboratively with researchers and users, to build these connections across disciplines and organizations, and to link users and producers of information in a more coherent way. And at this stage, this is more expressing my ignorance, because maybe some of these capabilities are already in place. But what are the effective ways of archiving and accessing co-produced knowledge? And I'll leave it there.
Thanks, Mark. And we'll hand it over to Stuart now.
Sounds great. Okay. Yeah, thanks, Mark. Thanks, Amanda, and thanks, Steve, for coordinating all of this effort. I want to build on the theme of the leading with this idea, which is the foundation of this session, is on climate anxiety. If you had, when Steve first invited me to participate, I don't think I would have come at this question with quite the level of anxiety as I was struck by in the recent weeks. Personally, I work on coral reefs and have been working in the Caribbean for many decades. A couple of weeks ago, got back from or went and visited down here in the Southern Caribbean, the island of Curacao, a set of coral reefs that I've been working in since my PhD dissertation. And before even showing up, I looked at the maps that are available of the climate data. These are degree heating weeks, the level of heat stress that are hitting these coral reef settings. And I'd never seen this color of purple ever displayed before. We think of corals being stressed at about 4-degree heating weeks or 8-degree heating weeks. And we're finding now that this deep purple is greater than 20-degree heating weeks. The environment looked dramatically different. A place that I had known to have perhaps some of the most resilient, seemingly never-ending coral reefs were a sea of white. The corals themselves having bleached, shown elements of death, with tiny little bits of tissue left. And it was heartbreaking. Climate is a real thing, and coral reefs are oftentimes ascribed to be that canary in the coal mine, the ecosystem that's most prone to climate stress, and perhaps one of our world's ecosystems is most likely to be destroyed due to the challenges of climate. It's certainly a real issue, but I want to give a case study here of coral reefs and thinking about how data may help us to find a fate that might be slightly different. We have an advantage, I could say, in the coral reef space in that we've been studying decline for quite some time, for better or for worse. The coral reef ecosystems, probably like most ecosystems on the planet, have been seeing dramatic changes. But it's been documented, it's been highlighted, and it's been talked about very, very openly for decades in these reef systems. One of my colleagues, Dr. Jim Porter from the University of Georgia, began a time series of imagery, great photo mosaic imagery from the reefs of Discovery Bay, Jamaica. His interest was in archiving what reefs look like, and he wanted to ask, with support from the National Science Foundation, a simple question: how do reefs change through time? And when he began this work in the 1970s, the idea was simply that you had a vibrant coral reef off the north coast of Jamaica in Discovery Bay Marine Lab, with corals overtopping corals. I'll ignore the sidebar where the NSF reviews he's told us the first couple times said, why would you study growth on corals? Corals are rocks. And he had to inform them they're actually animals that have interesting symbioses, and they can grow quite quickly. You can see all these staghorn corals here that would be overtopping one another. They can make thickets that are 2-3 meters tall. But lo and behold, what he thought was going to be a study of coral competition, growth, and the biology of this interesting group of reef-building organisms became one of the most prominent and visually stunning examples of collapse. The reefs off of this north coast of Jamaica had been stressed for some time. The population of Jamaica had increased past 1 million people. We're up to 2 million, exceeding 2 million. Due to economic situations, there was active fisheries that led to the depletion of the fish across the island. And what was believed to be a robust coral reef ecosystem actually had some parts missing. When Hurricane Allen struck, one of the biggest, the earliest and biggest category 5 hurricane to hit the north coast of Jamaica in 1980, it devastated the reefs. We can see just the branches that were remaining. There was some hope that these little branches, corals being colonial organisms, that they would regrow. But because the populations had dropped so dramatically, and because the food web was so altered, the little bits of coral tissue that remained were consumed by the predators that remained, these little snails and other organisms that ate the remnant tissue. Well, could there be recovery? You hope that there would be a way that the ecosystem would stay clean. You have these sea urchins here that were mowing the lawn, that were keeping the competitive algae at bay, and that provided some elements of hope that the reef would rebuild. 1983, later this year, an epizootic swept through the Caribbean and killed over 98% of all of these sea urchins. The sea urchins themselves, once gone, led with a history of socioeconomic disadvantage in Jamaica, so extensive fisheries that at that time were unregulated, left no herbivory in these reef ecosystems. And now what used to be a reef built of calcifiers, things that created calcium carbonate, that built the reefs that were around, and in atoll ecosystems like Mark talks about, created the reef itself, became a sea of seaweed. All of the green we see here now is seaweed with a few remnant coral colonies around. The story of reef loss is one that's common. It's a tale that's been told, and it's one that's been told through data. Colleagues who had been working on topics that were working alongside Dr. Porter were tracking what was happening, and were recording what these reefs look like. Dr. Terry Hughes found a way to collect some data and to track the change through time. Data telling us a story of an ecological response to disturbance. And we can see in data the time series of depletion of coral and the rise in the algae. What we had seen in that imagery from Dr. Porter was now memorialized in a graph by Dr. Hughes. But I'd like to point out that data sets like this are oftentimes focused. They're site-specific, and they're fairly personal. The data are collected by individual or small teams of observers, and they are describing individual cases. For us to move forward in this day and age of cumulative stresses, including climate on any ecosystem, we have to find a way to aggregate data, to build those data together. And in that, we've seen some challenges. Working a bit further on, earlier starting around 2010, Dr. Jeremy Jackson, a colleague of ours here at Scripps, began a campaign working with the Global Coral Reef Monitoring Network, trying to aggregate data from across the Caribbean to describe status and trends. This was a data aggregation opportunity for us to see what the Caribbean looked like, how the reefs had changed. And after a whole host of effort, came up with a map that looked like this, with observations of 35,000 quantitative surveys spanning a 40-year window, an impressive array of data, but with an effective time series focused on where these yellow dots are, only a subset of the sites where we could actually look in detail at trends that had changed. While this report was valuable and we were able to see we were able to start to learn through efforts much like Amanda's been talking about of extracting these data that exist in different places, Dr. Jackson and colleagues came up with what I found to be a very poignant part of this report. The quotation that we see here, most of the information in this report came from individual scientists who generously shared their data. But it took nearly 2 years to begin to use it reliably because of the diversity of metrics, formatting errors, and internal inconsistencies. As a sidebar, one of these formatting errors that I know of is a long-term data set that got lost because it was stored on a hard drive on one of the Caribbean islands. And when that hard drive got accessed again, it was being consumed by a pile of ants. This is devastating and heartbreaking. Much of the data was unusable because we could not verify locations, depths, and missing metadata. The situation is inexcusable, and no one should ever have to go through such an exercise again. Drama aside, I think that the point is very poignant. The data are our opportunity to learn from changes, but they're also, I would say, our opportunity to grow and to develop solutions to account for climate changes and to find solutions that will give us a tomorrow that looks somewhat in the direction that we want it to look like. I want to highlight the data challenges that are here and then talk about a case study where we're seeing some of these challenges getting overcome. I'm going to be specific here in saying that the challenges, I want to focus on these for coral reef ecological data. But I think that the problem could be generalized. I just don't want to speak for Mark and the distribution of tide gauges across the globe and other forms of ecological data. I will say that ecological data are heterogeneous. Much like Amanda pointed out, trying to find these data streams that are consistent, where the methods are consistent, can be really hard. Our colleagues at the National Center for Ecological Analysis and Synthesis, with partners from across the globe, have been working on some data science tools. But there's a consistent challenge in finding that interoperability of the data streams. That's implicit to a lot of ecological data. And I'll save the commentary about opinions and battles that exist that prevent these data from being quite as cross-comparable. When we deal with a lot of our climate problems, we're not thinking about a single location like Discovery Bay, Jamaica, but we're thinking about an entire set of ecosystems that may span the globe or all the world's tropics. These are the regions represented by the Global Coral Reef Monitoring Network. And we can imagine with this wide distribution of geographies, you're going to have a wide distribution of data opportunities and data demands. Data are collected by a whole host of individuals. And this is something that the community needs to address. We need to find standards. We need to find opportunities to collect the same data so that we can cross-talk without talking past each other, instead be talking in the same currency. And finally, money. And this is always the one that is a comment that makes it has very little value because we all come across it, but there is a real part to this. In a number of cases where we've tried to aggregate data, we've found that the final step of trying to find a location to build a data infrastructure has been a challenge. And this is a challenge that I recognize is one that can get overcome through a lot of our library systems. I want to give a case study of a way in which this is possible. In our efforts, like as Steve pointed out, we had a campaign that we called the 100 Island Challenge. We were trying to survey across geographies. We're working with partners in this co-development of data and co-design of the approach. In this effort, we used new technologies to collect what we found to be invaluable ecological data, image-based mapping products. On land, we take it for granted when we open up any of our satellite-based viewers. But underwater, it's a lot more challenging. Light doesn't travel as far and imagery is difficult to collect. But we've, through partnerships with engineers and other colleagues from in the management and scientific realms from across the globe, we found a way to operationalize the use of large area imaging. These data are information rich. They contain a whole host of data. In this case, just looking at the distribution of juvenile corals that are across it. It looks like a beautiful constellation. But these data hold value because they are information rich. From the standpoint of working with some of our colleagues in leadership, working with government leaders, traditional leaders, sharing what reefs may look like, through to dealing with natural disasters. In this case, there was a debate as to whether this oil exploration platform had crashed into a reef that people had photos on, and through a bathymetric map, we found an exact parallel of that, or exact inverse of the platform in the reef. This led to a resolution of an outstanding legal debate. But the challenge is, again, how do we take these data and how do we make them available? We can show it to that company trying to avoid paying, or we can share it with a leader, but how do we make them more open and available? This was a challenge of catastrophic size, or at least overwhelming size for our team, until we worked with our partners at the UC San Diego Library. Ho-Jung Yu, one of our great colleagues up at the library, spent time, patience, and a lot of intellectual energy helping to teach us how we could share these data. Rather than just have them and access them locally, how could we provide ways to open up accessibility? We've now worked with our library digital collections to create an ever-growing collection of these image-based data. We have opportunities we have over a petabyte of data that we're systematically uploading, creating these formats that fit standards for archival purposes, but also have the links that provide this direct access for our colleagues. I see this as an invaluable step forward. Our colleagues, through time, since the first stages of us documenting the decline of coral reefs, have been lamenting not having consistent monitoring data. Our management partners have shown these challenges in accessing any insights from partner geographies. And all of this happening in a day and age when technology is getting faster, better, and cheaper. This is tragic that the two things happen and we don't find a solution, much like Dr. Jackson pointed out. The solutions are there, the solutions are now. And the reason I highlight this, and the reason that we've put in that passion, is that that there are ways that we can take information we're learning from the planet and turn it not just into reports of loss, but into reports of how we may be able to restore or at least manage some of the problems into the future. I end with this imagery from a coral reef in the Central Pacific that went from there being lots of coral, a climate event that killed the coral. The pink is actually seaweed, not live coral. And then if we progress forward in time, we see that the corals are growing back. That I could go on and on the ecological reasons why we believe this is true. But what I find more important is providing access to these data so that the practitioners here from the Republic of Kiribati, or from Pacific Islands across the Pacific Ocean, or from our colleagues at any point on the planet, can have access to these data, to learn from these data, and to think about a solution for tomorrow. So with that, let me hand it back over to you, Steve, because I do think that we have an opportunity to share some, through the sharing of data, I think we have an opportunity to learn a bunch more to get through our climate anxiety.
Thanks, Stuart. And thanks also to Amanda and to Mark for those presentations. They give us the basis to, ask some questions. And to the people who were kind enough to sign up and come to this webinar, we thought long and hard about this and wanted to design in enough time for you really to ask just about any question. We have very diverse fields of expertise here with a lot of overlap. And, no question is a bad question. As a matter of fact, you may be asking or thinking of a question that other people are. And so now will be a great time through the Q&A mechanism in Zoom to ask your questions. And I'll try to get things started. And this is a jump ball for whoever wants to take it. But, what roles do you see emerging these days for librarians in supporting climate resilience beyond the traditional management, particularly in light of the evolving nature of climate data? Its accessibility and the ability to how to understand it, to interoperate with it for the librarians. Of course, that means fair. Where do libraries and librarians come into this process?
Okay,
Okay,
I can
Amanda, you
jump
look
in
like you.
first.
Yeah, I
I'm
know.
a librarian.
Go for it.
But I would love to hear from Stuart and or Mark on this too, because you guys are what it's all about in terms of support. But I mean, there are so many roles for librarians in this, ranging from stuff that I talked about with actual collections work to stuff that Stuart touched on with respect to helping them work through how to organize and share and structure data sets in our institutional repositories, to consulting from a data management plan at the very beginning of a project so that you have a plan going into the work that you're going to do, to offering things like carpentry sessions to teach graduate students and early career researchers best approaches for managing and documenting their data. I mean, it crosses so many different things. So depending on what kind of librarian you are, what your context is, what your skill set is, and what resourcing you have, there are tons of different ways to engage, as far as I'm concerned, from the librarian perspective.
I'll take a stab here and say that when I think about this, we can talk about climate anxiety, but I get data anxiety. In a day and age that observations are getting more facile and we can observe it more, I worry about losing that information, where to put it, and even how to share it. The partnerships that are emerging in terms of handling these data, getting ahead of it, and I'll highlight again our UC San Diego Digital Collections. It's just been such an invaluable partner in terms of helping us through that data anxiety. It's allowed us to stand up straight and to collect more data and to focus on the questions at hand, and not just to motivate our science, but then to provide that access to the students, to provide it to our partners, and to open up this ability to view in more locations. I think that's the starting point of it all, but I think it has to be done in partnership because we have to recognize we each have skills. And I will say that coming out of the gates, my skill was not in handling a petabyte of data.
Mark?
I ran a data center and I had no idea what I was doing in retrospect. So and nowadays with the fire hose of data that's coming along, it is just beyond the capability of most research teams to understand how to make that information available and useful. And we need experts to work with on this.
Okay, we have a question from the Q&A. And I won't read his name because maybe some people forget that there's an anonymous way to do this. But with all the money that libraries spend on commercial publishing deals, would it not be better to spend it on data sharing initiatives and allied communication efforts? Whoever wants to take that. So this is getting at, where are we putting our resources in terms of, what functions libraries play, and should they shift their focus and resources to data sharing initiatives, since, all three of you have highlighted that that's clearly what's needed.
I think every librarian you ask this question to would have a different answer. I feel like it's a yes and situation. Like a lot of university libraries are investing really heavily in digital infrastructure and repositories to help researchers share out their data sets. UCSD Library was a great example. Stanford Libraries has Stanford Digital Repository. But we also have to, faculty all the time are like, do we have a subscription to this? Like they want access to the journals. So we have to balance needs and balance our budget. I also want to push back a little bit and sort of ask, to what extent are funding agencies supporting all of the data that they're paying to create, right? Like we have NCEI through NOAA. In my world, NSF has BICO-DEMO and other, Arctic Data Center, other data centers and stuff, but is it enough? Is it appropriate? Are there, you know what I mean? Like I think there's responsibility should be shared, and the data management plan requirement is sort of a hint at that, right? Like they're having a sense like, oh gosh, all this research we're paying for is not being adequately shared and preserved. We need researchers to start thinking about that. But like I said at the start, I think it's a yes and. I think there needs to be a balance, and we can certainly be investing more, but our budgets are limited, and I would ask funding agencies to step up too.
Yeah,
Yeah,
I
go ahead.
hesitate to comment on where we allocate our funds with limited funds in any curatorial side. I will say that mandates that are starting to emerge for data transparency, data accessibility, et cetera, from funding agencies and from journals should be met with comparable investments in a place where those data are discoverable, with the support to manage it and the ability to throw out crap. And I apologize for saying that, but I do believe that we need to be maintaining basic standards for the different elements, and I think that and I think we do that as a professional society here, and I think we need to be putting that investment behind the support if we're going to mandate it.
All right, I'm gonna throw the next question at Mark first because he opted out of that one. So fair is fair. The next question is handling variability in data recording, the metrics, and in data handling, the metadata, seem to be one of our big challenges. It seems like we need to work between expert level knowledge and then expert level data management, not to mention library metadata standards. Are we stuck making a pipeline for our collections as data that is unique to each field and global repository?
Pass? No, I think I think Amanda better qualified to answer that one first.
I guess I would just say, since he ties it to collections as data at the end, that collections as data in the sort of environmental monitoring and environmental observations sphere, well, really any sphere, I guess, are only as useful as they are discoverable. And if I do all this work and put everything in standard digital repository, no one will ever find it. And so in some ways you have to embrace the discipline specific nature of the data you're working with and try and get it into the repositories and the places researchers are going to find it. I mean, we've been talking since I started in libraries about sort of generalist repositories and one metadata standard to rule them all, and how do you do all this? And I think I've just come to a place where I need to work within my community of practice with marine science and biodiversity researchers and put the data where it needs to go, that they'll find it and that they'll use it. So a certain amount of uniqueness and discipline specificity is okay. It just means that it's a lot more work. Because for me to create NCI level ISO 115, whatever metadata, is way more work than creating a title, subject, and keywords and column headers, right? Like, so yeah, anyway, that's what I would say about that.
I'll jump in and say one of the things that we're doing at the UC level is creating machines to do that work. We're using large language models that we're actually teaching to do that work because it really is kind of a one-to-one mapping in many situations. And if you can take a machine that will actually read papers, read the data, and come up with a README file and then produce standard metadata. That's one less step for the scientists to do that they only have to check. A lot of times you just have this almost writer's block about where do I start with metadata? What's enough? What am I doing? What things do I fill in? And we want to help and step in and take some of the more clerical work out of creating metadata for standard data sets. And that includes many times, and people will gasp when I say this, but that includes software used to produce the final data sets. So people run away from that, but I think that that's an essential part of it. All right. Wow. When it rains, it pours. Um, so I'm going to take these slightly out of order just to kind of shift it around. So one of the anonymous attendees says, I feel so much tension between the data deluge we're facing and the excellent data use cases y'all have amplified here today, and the proliferation of data centers and the water and the land that they use and the damage that they cause the environment. Do any of you feel that tension? And if so, how do you navigate that?
I,
I
I'll,
mean,
I'll
yeah,
take a
yeah, go ahead.
I'm happy to take a stab at this. I Not all data centers are created equally, and we've got much room for innovation. There are opportunities for us to be improving efficiency when it comes to our cyber infrastructure. We're working with a technology partner right now that we'll be able to share more about in the coming months on a way to try to follow, to track, quantify, report, and work to minimize our carbon emissions. And one of the key elements is by following the grid and by working by timing big jobs around when there's more renewable energy available, by working with the grid rather than against the grid. And a lot of this science is not immediate and can be kind of staged. So this is one opportunity. There are other opportunities in terms of efficient storage, making sure that we increase the efficiency of data standards. And right now, we don't really put too much effort on it because I believe that we're all holding on to the reins of a wild horse. That's the growth of the data, and we haven't had that comfort to be thinking in terms of the design. But I think by finding our technology partners, by us investing in it, much like a lot of our university campuses invest on green energy and increasing our local grids, disproportionately focusing that for our data centers, letting the university and academic systems be leaders on this front holds huge potential.
Yeah, and from our point of view of the producer of the data, particularly in the ocean field, it takes a lot of resources to take a ship out and to capture information. And so it puts all the more value, and we need to be exceptional caretakers of that information. So I do think that the data centers, when the data archiving is done well, it results in us having a more efficient way of observing the ocean. And maybe there's some comfort in knowing that we're saving on that side. But that's an important factor in the whole enterprise.
And I just would say
Okay.
extremely briefly that this is something I've only started to be thinking about more recently with the rise of AI and those kinds of data centers. It used to be that after we got our scanner and I sort of spun up our digitization program here at Miller, that I'd just be like, scan everything, upload everything. I'm in a tsunami zone. We need this stuff protected. Let's do it. And now when I'm approaching a new archive, I reflect on the question of, okay, what parts of this are essential to be scanned and put into SDR? And what parts of this can we just add to the finding aid and not digitize and not add to AWS storage in the cloud? So that is something that I'm thinking about as I move forward in my digital collection projects now.
Yeah, and I would say that, I think that as faculty and research staff at universities use these services, there is a job for IT infrastructure, which borders on the library, to be transparent about what types of resources are being consumed for the types of jobs that you may be submitting and the types of storage that you demand. Okay. The next question is, or comment question, says, at my research library, we have been talking about a need for a search tool that can work across multiple digital repositories, as often researchers may not know where data are stored. Do you see this as a need? Okay, there's supply side and there's demand side. And I'm going to put Stuart and Mark on the demand side, saying, yeah, I want a service. And then Amanda on the other side as the potential provider for the service. Ready, go.
Well, obviously, I mean, for my own research and for the work that our group does, that would be invaluable. And for the kind of data sets that I was talking about that are becoming more prevalent, where they are more community oriented and the community members are not going to have the time to, or perhaps the experience to go through an archive in the way that a researcher might, there needs to be very accessible entry points to the information. And these are for things like, these are for things that for more and more will have the practical applications, like what is the insurance going to be in your coastal zone? And what information went into that deliberation? And what is the, why did we build the pumping system? Was it the best economic choice given a city has few resources? Why did we decide to do that? And you're going to want to have all the information handy to really back up these sorts of choices. And again, there are these choices based on this intersection of social, economic, and physical data sets that, to the extent that they're all in a place where we can access them, then all the better.
I'll very briefly do that and then we'll hand it to the supply side, Amanda. But from the demand, Mark's talking about physical elements, and from the wildlife side, through our Center for Marine Biodiversity and Conservation, we work with wildlife conservation organizations and such, and there's a consistent interest in accessing data on climate futures, on habitat maps, on disease spread, and trying to find a way to act. While some of those data are becoming aggregated locally, they aren't cross-talking. Finding ways that we can build these cross-talk data platforms that are accessible to the non-information professional, to a person trying to work out which side of Mount Kilimanjaro to put a reserve to maintain a population of giraffes. These are important problems, and the data need to be accessible. We have big data now. I think there are opportunities, and I like the term, even though you can make people freak out, of digital twin to access these data, because you ask 3 people what a digital twin is, and they'll give you 3 answers. But I think that euphemism gets us close. Amanda, can you build us one?
I don't know if I can do that. Finding data is really hard. It's just like one of the hardest challenges that researchers face if they have a question they want to answer and they have to pull together data from all over the place. It's really hard. And I've seen a couple of different ways that communities have tried to get around this. In my sphere, one resource I think that's really useful is Data One. So this is a federated repository of repositories that lets you search across, an entire planet of Earth observation data. So LTER data, Arctic Data Center data, all kinds of stuff goes into Data One. And it's a great place to go and shop for environmental data if that's what you're looking for. But if you're in Mark's situation and you want to find city data on flooding and environmental data, like that is a really intractable problem. The only other place that I've seen where you can search across, there's like data.gov and things like that. But a sort of data librarian hack that I used to do a lot was to go to the DataCite search. So the DataCite is the organization that issues DOIs to data sets. And you can search their entire database of DOIs. So that could be data, any kind of data, as long as it has a DOI, you could search it. Now, is that search interface super great? I could have a few suggestions, but that assumes the data you're looking for has a DOI, right? And there's all kinds of data out there that doesn't. So this is a really hard problem, and I don't know that we have necessarily solved it.
Yeah, some of the data that I've been dealing with in a side project for Flint water quality, those data are not born digital. And so the right away that makes it really hard to find. And I think that there's an incentive at the local level not to ascribe, nefariousness to any government official, but to put the data in non-scrapable PDFs. Makes it really difficult to aggregate. So you can go and find an individual file, but the data are in tables and they're maybe not Unicode, so you can't get the actual numbers out. So data not born digital really throws a curveball at that whole problem. So, have a couple of questions here from a prospective graduate student for Scripps, who mentioned Mark's epiphany of all the data that's missed when indigenous knowledge is not involved in the scientific process. And I think that's more of a comment, but then there's sort of and I'm going to give this sort of a Mark Stewart question, even though it says it's for Stewart. In what ways have your studies informed local communities for their local conservation efforts, coastal resilient efforts, and/or ocean protection policy? And has this assisted with and I'm going to add, even the community's climate anxiety?
I'll take a stab at it. We have been working closely with our partners in the geographies where we work. We show up to locations with a mixture of scientific or academic questions, but with an understanding that we're not in a day and age to simply study things academically when they're ecosystems of interest and importance. There's well beyond the permitting, there's just the ability to feel welcome to even conduct the work, and that's a primary importance to us. We only work in locations where traditional leadership, in addition to permitting and the society, are of interest. The community has interest in the efforts. Has that work been actioned? Yes, and it works best when in the locations where we have strong partnerships with the governmental agencies, the traditional leadership and some of the elders or the youth that are oftentimes making those data actionable, NGOs or different organizations. We try to work with those partners who have that maintain the relationships, that are the creative individuals who can digest and share a lot of this information. We collect the data in concert in every way when there's time and bandwidth available. When I talk about capacity, I'm simply talking about time availability, because people are so overstrung with their efforts. We have seen different management plans from national to community level that have gotten implemented and that are reinforced by seeing what's in the reef and by seeing how things are changing in response to it. And I will say one thing just on to reduce the climate anxiety. I'll say that what I read in the academic literature about the impacts of corals, I would think that every coral would be dead 10 times over by now, based upon the overwhelming bias towards this focus on cause and effect, temperature and death. There's a lot of growth, and in a number of the geographies where we work, I've had colleagues come up to me almost as a confessional and say, you know what, a lot of things are dying, but over here there's a reef that's been growing. And these are some of the corals that may be adapting, they may be migrating, there may be different populations. I'm not saying that everything's fine. Climate's a real thing, and it's really putting a stress on these coral ecosystems. But there are some places where the management's keeping things around. And this is great to have the academic lens be able to listen and then to work with, and for the messaging not to be based simply upon a single story with an agenda, but instead to be democratized so that we can all see what's going on, learn from it, and derive our own conclusions, lean in on the optimism and the pessimism based upon how people want to see it and communities want to use it. To me, that's of primary importance.
Mark, you might be muted.
Sorry, a lot of the partnership.
There we go.
A lot of the partnership projects we have are motivated by communities wanting to develop a climate adaptation plan or a real threat. And we also are working a lot with heat waves and impacts on human health. And we're trying to bring the information as close to the user as possible so that they have their own agency and how the information is gathered, often with their assistance, with sensors in their location or sensors that they help us sponsor. We're really trying to get them to understand not only what the data tells you, but just the value in gathering information and what the process of that gathering information, to me, is what connects people to the environment in ways that are hard to see otherwise. Climate change is, we talk about this event or that storm or this, but it's a very slow moving train right now. And so, but when you see the data and when you understand at that level what the change is, it brings a whole different perspective. So we're working with schools to develop curriculum. We're putting weather stations in schools so that they have their own climate monitoring stations. Does it help with anxiety? I don't know, but the biggest anxiety for me is just not knowing. So it certainly helps in that way.
All right, I want to be respectful of the time, and I think that Amanda Bozar will probably have some wrap up she needs to do. So I have a final question, and we'll take it in reverse order. We'll go Stuart, Mark, and finally Amanda. What concrete steps can libraries and librarians take to help reduce climate anxiety in their communities? So that community could be university, it could be, a neighborhood community, it could be state or federal level. What can they do to reduce climate anxiety in their communities while maintaining scientific accuracy, but balancing that by not minimizing the seriousness of climate challenges? I think that's something that Mark just mentioned. And so each of you, take a swipe at it. Stuart, Mark, and then Amanda.
I'll say think about programs to increase the accessibility and the digest of the data themselves. I have a dream, and this is going to be focused on the geographies where we work, to start building a support for ocean librarians. In the Pacific, in some of the Pacific Islands where we work, there are a lot of data, but then the school groups, the communities, some of the elders don't necessarily have access to it, let alone some of the challenges of the digital data being accessible with limited bandwidth through cell and or mobile devices. So if you think of the ways that we tried to open up accessibility to books with a van that would drive around and drive books, I'm thinking of community libraries, having a library that provides that access with the digest mechanisms, with the interpretation, with all of the forms of the human access to the data that we need. This is a dream that I have, and I think it's an opportunity to Mark's point, to make sure that we're transparent about the breadth of the data, the reality of it, and then to build our own conclusions as a knowledgeable populace.
I'm not sure I have a recommendation on what to do, but I do have the feeling that there's a lot of appreciation for what you're doing. And maybe that's something you need to hear more often from the research side. But we are just indebted to you for being a trusted source of information. And coming out of this, I realized in my grants, I need to include funding for supporting this sort of work. I can't just take it for granted that the library is going to handle this for me, particularly if I want it to be done at sort of this higher level that I'm asking for. So I just am just very appreciative, and also I want to be as supportive as I can going forward.
Thank you, Mark. From the library perspective, I would say that, for myself and the researchers and the research community that I support, folks feel anxiety when they feel like they lack the information they need. Either they don't have it, they don't know how to find it, or they have it and they don't know how to share it. And they also feel anxiety when they have a lack of agency. They don't know what to do. And so in my role, and I think we've all touched on this, I look for ways that I can help them get things done, either through finding and accessing information, figuring out how to share their own information, or by producing from my archives information that helps them solve problems that they're trying to address. So I've said it before, librarians are helpers. So I encourage everyone to think broadly about their role and their resources and their context and how they can be of support from whatever perspective makes sense to them to the research community where they are.
Well, I'd like to say thanks to all of our panelists. Thanks for, give it 100% poll to poll. And I'm going to hand it back to Amanda Bozar.
Thank you so much, Steve, and everyone, for your presentations. They were just excellent. It was so engaging. I was like, how is it already 5 o'clock? I'm shocked. Well, 5 o'clock on our coast. So I have up here just some reminders. We will have a climate circle on this if you want to talk more about it. Join us on the 13th for that kind of informal conversation. And then we'll be meeting up again as a large group for a formal session on January 30th for Indigenous Knowledge and Climate Collaboration. The video for this session will be posted online within the next 2 to 3 days. So once that's up, you'll be able to share it broadly, and we encourage you to do so. So thank you so much for attending. Thank you to all of our panelists. And I hope you all have a wonderful evening. Bye-bye, everybody.